Hey, everybody, and welcome back to the Kodiak Shack podcast. I have Alex and James from ShockTech, and they're going to talk to us about REAP and some other programs that they have, maybe working with NASA, some astronauts, stuff like that. But again, we have some sponsors coming out, so thank you for that. And then also, if you want to donate, that'll be in the show notes. And now, a word from our sponsor. Crowdbotics Defense is a data analytics software company serving the United States Air Force. They make it easy for active duty servicemen and women to turn their ideas into products and tag team DoD adoption. If you or someone you know has an idea for how tech can speed up your team, increase efficiency, or make your life easier, reach out to Crowdbotics Defense to talk it through. Crowdbotics Defense will help you define your project scope, timeline, and cost, and work with you to secure the budget you need to build it. Any product built and adopted by DoD will be credited to you as the collaborator. Reach out to Julian at crowdbotics.com for help. That's Julian, Julian, at crowdbotics, crowdbotics.com. Also, there will be a link in the show notes. Everybody I talk to in the DoD sees inefficiencies that could be streamlined or rectified with the hard work of software engineers and people in the United States Air Force. So work with Crowdbotics Defense to make a product that you are proud of and you're happy to work with. But we'll get right into it with Alex and James. So thank you for being here today, and go ahead and tell us about yourself.
Go ahead, James. You got it.
My name is James.rall, so I lead the Research Engineering and Development Department at ShockTech. I have a bachelor's degree in physics, math, and chemistry, and then I have a PhD in physics from West Virginia University. The way that I sort of came into, at least into ShockTech, I was working at an SBIR company previously. And so I got a call from somebody saying, hey, we need people to help us with writing proposals, doing SBIR projects, getting these out and running. When I came to ShockTech, it was very different from the previous SBIR company that I worked for, whereas here they really do a lot of production stuff. So we do a lot of manufacturing production in-house, which is contrary to quite a few of the other SBIR companies that I've seen. So.
Nice.
So, alex.faust, I have one degree, aerospace engineering from Purdue. I am from Indiana historically, and until recently, just popped over to Ohio. But I've been with the company about a year. I'm the director of business development for ShockTech, so more sales side than engineering, but certainly my background helps me a little bit. So ShockTech primarily does shock and vibration control for defense contractors, primes, government, generally in the naval kind of space. But recently we've been venturing more into aerospace, missiles, space, and now that commercial space has taken off, Blue Origin, SpaceX, and folks like that, vibration control is a big concern for sensitive electronics, for experiments going long distances and needing very precise measurement capabilities. So that's kind of where ShockTech starts, and I guess let James roll into why we're here today.
Yeah, well, and before we get there, Alex, I don't want you to feel bad. You only have one major, but at least it's a good one, because I had a geography major. And so, I probably don't deserve to be in this conversation. So don't feel bad. We got the PhD here. But so it's kind of interesting because you talk about that. And I think a lot of people don't realize how much that, the shock and the issue of vibrations can affect things, because we always get told, at least in F-16s or in airplanes, like, hey, these things have to be able to withstand the rigors of what you're putting them through. So that being said, James, go ahead and kind of explain. So they have a product called REAP, and then I'll let James kind of dig into it and kind of tell us exactly how it works, what it looks like, try to build a picture for you.
Yeah, so REAP is so it stands for Reusable Energy Abatement Pad. When we talk about aerial delivery, most of the time the Air Force has to train for these for the air crew and the pilots. And so they day in and day out just drop these bundles, and each of the bundles have a one-time use energy dissipation pad for it. We call it honeycomb. It's just a cardboard piece that they put between the payload and the skid board. When it hits the ground, it just crushes it and it destroys it, and that's where you get the energy dissipation. So we developed a reusable product for them to replace that for training purposes in CDSs or container delivery systems. And so that's what we're looking at. So we did it through the SBIR program through AFWorks. We started in 2019, got qualified to do operational testing at the end of last year in December. And that's what we've been doing from this year's operational testing, and then also selling to different operations.
Nice. And so, because I kind of struggle to imagine, and obviously I'd never, the airdrops I didn't, they needed to slow down quick and detonate and whatnot. But in this case, we have, when I saw the picture, it reminded me of a purple mattress, if you will. It's not purple, it's black, but it's that. It's these, I guess is silicone the word, or rubber, squares that you would create to create that honeycomb, but of a different material, right?
Yeah. So it's made out of an elastomer that we formulated in-house. And yeah, it's exactly right. We made it so it's modular, so you can put it all together. You can disassemble it. The way that regular honeycomb is shipped right now is in about 9-foot boxes, so 9 foot by 5 feet, and then about maybe 4 or 5 feet tall. So it's very, very large boxes. So those just take up a lot of space, especially when you're talking about shipping it over to Kadena or Okinawa, Japan, or anything overseas. That's just a lot of space that you could be putting other things towards. And so ours really fits. The size of one CDS fits into like a paper box, the boxes that paper come into, instead of a 9 foot big long thing that takes up all the space.
Yeah, and one thing that I originally kind of struggled to really grasp on exactly where it's going. So say we have like I don't know, a Humvee or some sort of like ATV that is going to be dropped out of the back. Like, where is this going to live kind of in that pallet construction? Just so people kind of understand what's being replaced and what part of the drop is absorbing the shock.
Yeah, you usually have the bottom plate, which is the one that hits the ground, and then you have your payload, which in the case of container delivery systems, it's some type of dummy weight. It's, a metal cage or water barrels or something like that. It could be, you could think of it as Humvee. And so in between that bottom plate that hits the ground and whatever your payload is, if it's water or a Humvee, that's where your energy dissipation occurs. So right now for like Humvees, they have these stacks of honeycombs, so they stack them up to about 4 or 5 feet high, in order to give it not only to provide the energy dissipation, but also to make it so it's not in contact with that skid board or the ground plate that or the plate that hits the ground.
And you're saying they're putting 4 or 5 feet of this cardboard honeycomb, and then when it
Yeah.
hits the ground, that all becomes like a half inch of honeycomb at
Well,
the end.
it's actually very interesting. It doesn't really destroy most of it, and even this project was started through AATC in the Special Warfare Division because they have the SRTV for their rescue squadrons for Guardian Angels. And sometimes, so it's supposed to compress enough to get the tires onto the board and then they can just drive it off. But there's so much engineering, like they put so much of it that it doesn't even do that. So it doesn't even compress enough to get the tires onto the ground or onto the board to drive it off. So a lot of times they'll have to push the vehicle off of these stacks of honeycomb. And I think it's really, they do 4 or 5 feet because it needs to make up that gap from where the skid board is or where the bottom, the one that hits the ground, up to the vehicle. So we initially proposed to design like structures so that way it's like a telescopic structure because you only really need maybe 3 inches or 6 inches of energy dissipation for that vehicle, but they use all 4 or 5 feet because that's how they construct it. Yeah.
Yeah, which is, it's funny that you always think that you're kind of you're like the only one, for a long time they said the Viper reset for the F-16, like, oh, turn it off and turn it back on. And then you talk to anybody in tech or anybody who does anything, they're like, yeah, just turn it off and turn it back on. Like, it's not like the F-16 was the only thing that was a solution for. But I feel like in this case, the same thing where, it's like, hey, you don't want to land short, so just a little extra airspeed. And then, like the tech order is written with a little extra airspeed, and then the pilot flies it with a little extra airspeed. And then all of a sudden we're like, 10 knots fast because everybody just adds a little bit more because it's like, hey, it can't hurt. And then we run planes off the end of runways, or we have to push vehicles off of their delivery systems because we put too much cardboard. So see, that's pretty cool. What would you say? I mean, developing all of that, where was kind of the pinch points, when you're like, okay, we're going to replace this with this polymer or elastomer rather. Where did you kind of struggle to kind of develop that and create something that could do what you were attempting to? Because I assume it's not just, it came out of the box perfect.
Yeah, we went through quite a few iterations. So the first one was once we got feedback from the customer. This product wasn't initially part of our phase one, but during the phase one discovery of what do the end users want, what are they looking for, this product sort of developed out of those conversations. And it did happen to be coincide with what our main focus was for the SBIR, but it was nice that this one was like, yeah, we can do this, and it aligns here for what they're looking for. So after we got the customer feedback, we did initially we looked at 3 different designs and seeing which one gave us balance between performance, weight, any of the other requirements, and then from there we took this modular one because we saw the benefits not just of what the end user was talking about, but these other benefits of being able to ship it in a smaller package size, um, saving on that cost for shipping costs, to store it. A lot of times these bases will have a whole trailer or some type of container. You can think of it as sort of like just a storage unit for these honeycomb. And so now they can get rid of that and they can put that space towards something else. So it just added so many more benefits than the other designs that we were looking at. I think the biggest thing that was brought up, especially early on, was this qualification, is that we had no idea that even though it's aerial delivery and the U.S. Air Force does a lot of it, is that once the container or once the payload goes outside of the aircraft, it's considered now Army domain. So Army has all the qualifications, all the regulations that the Army does on those. And so even though we were working with the Air Force, we still needed to go through the Army and say, okay, well, what is the qualifications? What is the certifications for that? And being able to not just look at it, but also find a way around it, I guess, is the way that we did it. Is that right now, REAP is very limited in scope. So it's only applied for training purposes with CDSs through the Air Force. And that was because the qualifications that the Army has was so tailored to the honeycomb that it required it to be packaged in like a 9-foot box, which takes away one complete aspect of it. So we knew we weren't going to make the qualifications that the Army wanted or at least what they have for the honeycomb. And so we found this way around to do a UAT unilateral airdrop training authorization through the Air Force. And so, yeah, and that was mainly through Master Sergeant Holzenbeck from Fort Lee. He went out, saw the drops, and then he came up with the UAT, and that's how we've been able to at least get the Air Force people and the end users to be able to operationally drop it. And then once they operationally drop it, we can gather that feedback so that way we're not, waiting on the Army to do a full qualification and certification of the product.
Yeah, it's very Army of them. I've had an opportunity to, well, I don't want to call it an opportunity. I've interacted with the Army, uh, where so Holloman Air Force Base was my last base, and the airspace, which is actually very good in the continental United States, but the Army owns it, and they do a ton of testing in there. And the funny thing is working with the Army, but it's all Army people, so they don't do air stuff very much. So they say, you know, they'll have a restriction for like 45 minutes in the morning and then 45 minutes in the afternoon. But they just make the restriction for the whole day. Like, you can't fly there. And you're like, why not? And they're like, oh, it's easier this way. And it's like, for who is it easier for? Like, so it's, you know, I can say that stuff because my uncle's in the Army Reserve, so it's cool. You know, I can get away with it. But Alex, did you want to add something? I thought you might be.
Yeah, just a couple of things. I mean, the classic, like, writing the specification around the thing that you're using today. So the Army and the Air Force are using the cardboard honeycomb, and so everything that they've ever written on how to use it is just for that, instead of taking a step up and writing a true specification where the load, you know, dissipation of energy must be at this rate, or the thickness of something you're going to pack depending on the payload needs to be X, right? And they just wrote it all for honeycomb, which is part of the trouble we're running up against. Now, over time, we can probably change that, right? With time and with some folks who will help us do that. But initially, it makes it incredibly difficult to make a viable product for the DoD, just like bar none, right?
Yeah.
But I did want to add one thing, James. You mentioned storage, you mentioned shipping. What other specific requirements were there when we were doing the phase one for this solution? I know there were a few more.
Uh, yeah, there was quite a few that they had. In terms of the end users, really they wanted something that was reusable, something that they could bring the CDS bundle back and just pretty much turn it right side up, fill it back with water, put a new parachute on, and put it back onto one of their aircraft. And that was the main one. They didn't really care too much about some of these others. We did try to make the design as similar to honeycomb as possible, so that way there's less barrier for them to accept it into the community. Um, but I think that was the primary one. They didn't even care about weight. You know, they were like, if you make it reusable, we don't really care about weight. A lot of shops will have cranes to lift them up and transport them, and you know, they already deal with that aspect of things a lot of times. So there really wasn't too many requirements from the end user, but we put a lot of requirements on ourselves to make sure that we had that path to go into the market, right?
Yeah. The one question I had, and I don't know if you guys have done all this or how much you can get into it, but so for the kind of the absorption of the energy absorption and that shock absorption, I mean, are you actually doing like testing on how much the REAP is actually slowing down the thing and how it compares to the honeycomb?
Yeah, we've done in our phase two, we did laboratory tests. So we developed a drop tower, we built it, and then we compared 1 square foot of paper honeycomb to 1 square foot of REAP. And so we saw about comparable performances. REAP does give a little bit more of a rebound. And so, but again, the end users, they don't really care about, so it jumps up a little bit higher, you know. Um, we are doing operational. We did operational starting last November was the one to do qualification to get the UAT. And then we did operations with Master Sergeant Strout at Patrick Space Force Base. And then that one we did a direct comparison between what does REAP do and what does Honeycomb do. That one was interesting because there was some type of cut in the gore for the parachute. So the REAP bundle came down faster, and so it hit the ground faster. It hit the ground at like an odd angle, but it dissipated more than what the honeycomb did. So the honeycomb dissipated, I think it was somewhere around 70 or 75%. And then for the reap, we were looking, we dissipated about 85. And then we also looked at rebound, how much time there was in the air after the first impact to the second. And then we saw about a 20% improvement for rebound energy, even with that. Um, so we do see a comparable performance, but also a little bit of a performance gain.
Okay, nice. The one question I always have is so working with end users, how has that been? Have you had a good experience, a lot of input, a lot of feedback? Because obviously, every end user, it's their secondary, maybe even their third job. So have you had a lot of kind of data flow back and forth and a lot of good experiences with that?
Yeah, overall, it's been really positive. During the phase one, we went and visited about a handful of bases. We even met with a few Marines and Army folks when we were out in Japan. So we traveled all the way out to Japan and met them out there. Um, and overall, it's been awesome working with the Air Force personnel that we have. Anytime we want to come out and testing, we say, hey, can we come out and test? And they're all willing to come out and have us on their base and do any type of testing. And we have direct contact um, uh, with Fort Lee through Hulsenbeck to make sure that any type of conflicts or any type of questions that they have about, okay, is this actually authorized? Then we're able to have that line of communication to say, yeah, we're able to add sensors onto it on the pallets and do this or that, or if we want them to do different rigging, then he's always a phone call away that he'll pick up and answer any questions that they have. So
Nice. Well, that's good.
And
The
I would just add, even though this is authorized for training, the folks that are using it are dropping 10 times a week. Is that fair, James?
uh, it depends on the base. So for example, Kadena has a maximum CDSs that they can drop, which is 10. Um, For something like Little Rock Air Force Base, which is one of the larger ones, they're doing somewhere probably around 50 to 75 a week. Um, but it doesn't necessarily mean that they're going to be dropping the same bundle over and over. A lot of times they'll have the inspector come once a week. So at the beginning of the week on Monday, they'll inspect all the bundles for the week, and then they'll drop those and then inspect for the next week on the following Monday. So
So where I'm going though is if they're using traditional honeycomb material and it's all one time use, it's a ton of garbage or a ton of recycling, however you want to look at it.
yeah.
But with our reusable option, they could re-rig and roll out the next day, or a day removed, or whatever. And so we've been able to be a part of a bunch of drops and get a ton of data back from the actual end users, which has been really great.
Yeah, that's good. Well, and I think where'd you guys go in Japan?
Kadena.
Like Kadena. Okay. How'd you like Okinawa? Was it pretty cool?
Yeah, it was a little blast from the past. It seems like
Yeah.
a lot of the companies that went out of business in the States are still open there, and yeah,
Just swung by Blockbuster, stuff like that. The
yeah,
yeah, my first assignment in the combat air force was up in northern Japan, and it was a good time. I enjoyed it. It was definitely a cool culture up there, and it's just different. It seemed like a much smaller, just a smaller bubble that you live your life in when you were overseas. So that's cool.
yeah.
Neither of you guys have any military experience, right?
No,
Yeah. So how was it checking out a military base for the first time?
I've been on several of them. My dad was in the Air
Okay.
Force, and
Oh,
so
nice.
I've been on quite a few throughout the years. And then my ex-wife was Army, so yeah,
Oh, okay. So you a lot of exposure then. What about you, Alex?
yeah.
So I somehow missed that trip to Japan. I don't know if I was on board
Oh.
yet. I would have liked to go. But I've been on a few bases in my former life, doing jet engine work for 3M. So um, always good experiences. The folks there are always very knowledgeable, and in terms of like customers who are willing to give you any kind of data, all the military folks I've worked with have been fantastic.
Yeah.
Where
Well, that's good.
uh, you know, private company customers generally kind of hoard their things and maybe don't want to share everything. But if the government's paying, it's all fair game.
Yeah, one a lot of times the military doesn't share data because they don't know how or they don't know where it's stored. It's not that they don't want to; it's just they're like, who knows how to access that. The was it solid rocket motors, or what were you working on motors for 3M?
So for 3M, I was part of their adhesives and surface protection group for the aerospace group, and so we did jet engines. So Pratt, GE, Rolls-Royce, those guys.
Nice.
So yeah, rotary turbojet type.
So the F-16, the U.S. one at least, the ones I guess, has 4 different motor options. So I know which one's my favorite. But if you've worked with the Pratts and the GE, do you know from your side of the house, do you have a preferred motor?
So it's probably just from my sheer experience and working with it was the motor for the F-35. So that's I think it's the F-135 motor for Pratt & Whitney. It is a beautiful piece of machinery. And so I got to see that close up in assembly in Hartford there where it was being put together. It was incredible. So
Yeah.
I obviously haven't gotten to ride one yet, but someday.
Yeah, you got to work on that. You got to start making stuff for fighter pilots, and they'll take you up in the jet. Yeah. Well, that's pretty awesome. So with ShockTech, obviously you guys are doing stuff all over the place. So if you were kind of boil down kind of the most basic form of, hey, this vibration absorption or any of that, like what are you looking at when someone says like, hey, we need to protect these parts? Like, how do you kind of walk through that process of how we're going to protect them?
So I'll speak from my side, James, and then I'll let you take the red side. In general, when we've got customers looking for a solution, so generally they know they have a problem, they have some understanding of what that problem is, and then potentially how they might want to approach it. So I'll give an example here. The Navy's got a server rack that goes in one of their boats. Doesn't matter what boat, right? So it's essentially the size of a file cabinet, if you will, and it's full of electronics. Well, all those electronics have maximum loads that they can sustain and still operate. And there's a couple different testing specifications. I think they both fall under 901. There's a D and an E is the mil spec testing. And so they'll come to us and say, hey, this is our system. It weighs 1,000 kilograms. We're going to be subject to 901E barge testing. We know what the input of that shock and vibration is going to be. And so based on the parameters of that test, we can design a system to isolate that. So either energy absorption mounting points from the deck to the system, or maybe an enclosure that mounts that thing in 3 dimensions. And so basically when, in the event that a boat is hit with a bomb or a missile or whatever, a shock input to the system won't damage the electronics. And I think the whole background of this company and really where we've been successful is from 2001, I think the USS Cole was bombed, and I believe the boat sat dead in the water for a few days. And so back up, the government said, we never want this to happen again. We want all of the systems on a boat to be hardened to this standard. And so if you think about all systems, air compressors, fuel pumps, any kind of hydraulics, if you've got an aircraft carrier, bringing jets up, they all have to manage this very specific shock input. And so that's really where we work well. I know that's a lot of information, but that would be potentially how we approach a problem.
Yeah, cool. James, you anything to add to that?
Yeah, the R&D department's a little bit different where a lot of times they might not know what their thing is. For example, NASA says, we want you to develop this isolator, but they don't know what size it is, and They just want the best performance that they have, right? They're like, this is the one requirement we really care about, and then that's it. So a lot of times we might be dealing with unknowns, or like you said, the Air Force people might know that there might be data out there, but they may not know where it's at, and so coming up with estimates on some of the things that we might need to know to develop a solution. I think the other thing is a lot of times these are retrofit, like, a lot of times people don't have vibration control and shock mitigation in their mind when they're building a system. And so they'll start testing and then realize that they have a problem. So an example is like some of the helicopters that have the Gatling guns. When they had the Gatling guns going off, it would trip a circuit breaker and then it would stop the gun. And it was all just a vibration and control. And one of the first comments is, well, if you redesign the helicopter, we can make this perfect for you. But no, they're not going to redesign the helicopter. So you have to put in and you have to work with what they have, which sometimes it's difficult, right? Like if you think of these things before you start the design, you can plan for them. But if you're trying to put something in, you have, height and size and weight restrictions. But at least from the red department, we deal with things that are very abstract. So a lot of times we'll look at SBIR topics and they'll say, for example, we have an army that's starting up in the next week where they're looking at suspension improvements. So they say, we just need suspension improvements for the ambulance Humvee that we have. And then you can propose whatever you want as long as you're improving the suspension. So, yeah.
Well, that's cool. Well, it's funny that you gave that as an example because, again, the F-16, just going back to that one, there's this odd thing that happens in a lot of the F-16s, and no one, at least none of the pilots know why, where the gun, so the Gatling gun, it's a 6-barrel, 100 rounds per second, 20 millimeter cannon that you shoot, and then every once in a while your radio just doesn't work. And I mean, it definitely shakes your feelings out when you shoot it. Kind of your whole vision and everything goes blurry as you're shooting, and you're like, "That was awesome." And then you climb up, and you don't hear anybody say anything. And you're like, "Ah, that's weird." I feel like, but if you just enter a new frequency and then re-enter your old frequency, everything works. And you're like, "Okay, well, sure." Then maybe the F-16 needs a little shock absorption or something. That thing, so with that. And kind of what you talked about was the end users. There's so many times where I feel like, and kind of with your SBIR 1, where it was like, hey, we got hired to do this, but then we really realized that they actually needed that. I feel like there's so much of that out there. And does that happen with a lot of people, not just DoD people, just kind of all customers? You kind of realize there's problem sets that they didn't even realize were problems until they started talking to pros?
100%. Yeah. I could give you some examples in the private sector, but shock and vibration is kind of a niche thing. And there are absolutely folks out there working for big primes who know what they're talking about. They know what they need, and they'll come to us with a half-baked design and say, hey, I need you to build this. And we absolutely do that. But for the most part, it's here's my system. Here's the problems I'm seeing. We have no idea. Or we know there's going to be a problem. Can you help us fix it?
Yeah. The one random question, and it's probably not even a worthwhile question, but it's just on my mind. So when you're thinking of these kind of shock absorptions, so one massive input of energy versus like a lot of small inputs of energy, is that a big difference when you're looking at shock absorption and how you're going to withstand these things? So like a slight wing flap on an aircraft always through flight versus like massive impacts from something. Is that a big difference for the two solutions?
Yeah, I mean, you have to take both into consideration. So even though you might have to worry about shock, you still have to worry about the vibrations, right? And so some of the ideas is like if you vibrate a wing at a certain frequency, you can unscrew the fasteners, and if you vibrate at a different frequency, you can screw them in, right? And so depending on those vibrations, so whenever you're talking about retrofitting, you also need to look at not only making sure that you fix whatever it is that your objective is, but you're also not putting it into a worst case scenario for like vibration, right? So you
Yeah.
can mitigate shock, but then if you're worse for vibration, it might not be good for them. So
Yeah, that makes sense. So
Yeah,
what are
and
some of the,
there's
oh,
sorry, just one more thing
oh
to
yeah.
add that it happens quite a bit in the shock space where you get a massive input, and if you don't tune your isolators correctly, you can actually get amplification of the input instead of mitigation. Um, that's it's all we get in the weeds on frequencies and how that all works, but it's all math.
Yeah, well, that's cool. Yeah, the my son's good at math. I am less so. But the yeah, well, when you go to pilot training, obviously they get like aero majors and all these big brains, and they have like a geography major sitting there, and they're talking about like dynamically unstable, and I'm like, whew, when are we gonna start flying airplanes, guys? Because this
Yeah,
is
where's
not
the
my strong
throttle and
suit.
where do I point the nose, right?
Exactly. Like it's easy, fly higher, fly lower. But once we got into like the basics of aerodynamics, I was like, you lost me. But luckily that was only like an hour long class, so it didn't hinder me. So what would you say kind of in the cyberspace? Because you guys are pretty much kind of commercial rollout, right? So you guys are effectively under a Cyber 3 esque now. So what's kind of the future? Where are you guys going? What are you looking to do next with the Reap? And then kind of how's that rollout look, at least from where you guys are standing?
yeah, we are in the phase three, and we've gotten several phase three contracts through different military bases. I was just updating the ones that came in the last week. It's the end of year funding, so
Yeah.
everybody's trying to get like everything bought and purchased under FY22. So, um, but really, we're looking at the feedback from the end users. We want to make sure that this is like a long-term product for them to use and not a short-term. So we're getting feedback on whether they want a different color or if they want some type of design changes. They want something where they can start tying pieces together. So we're going to be doing some design changes to do that, where you can connect the different modules that we have with it. And then we'll do like a final design of, okay, this is what they really want, probably early next year. And then we are also working with some of the test squadrons out in Nellis Air Force Base that does some of the Guardian Angel units, outfitting them. And so they want to use REAP for some operational uses. So they want to take it beyond the training and into the operational space. And again, it's right now it's only limited to CDSs because that's what the US UAT calls for. Um, but more than likely, it's going to start branching out to different training loads. And then again, if we can get development with that test squadron out in Nellis, then it'll go into the operational side of things.
And one more thing to add on that side is, I think down the road as this becomes commercially viable, there can absolutely be iterations of something that dissipates more energy or is a little bit thinner, a little bit lighter, or however the end user needs that to be. But specifically looking at other spaces, key in my mind is the humanitarian aid side. So Red Cross or Red Crescent, they're dropping stuff out of planes all the time. Now, the military is probably involved there somehow doing that, but there's nothing that says this can't be used for that either.
Yeah, that makes sense. And I mean, because it seems like there's a lot of versatility in different use cases that you haven't already explored. So hopefully, kind of people reach out and do that. What would you say one of the other programs that you guys are working on? One of the other cool ones that's out there that you're excited to talk about?
The one that's really big on our tray is the NASA project. So we're developing an isolator for NASA and specifically for optical communication devices. So you have these satellites that typically use RF, so radio frequency, to transmit communication, but they're trying to switch over to optical, and they've been doing this in this process for 20, 30 years to go over to optical, which is fairly easy, or I guess maybe not easy, It's fairly straightforward when you're close to the Earth and you're beaming something, that's one of the satellites down to a ground station. But when you're talking about beaming something from, let's say, Jupiter and all the way back to the Earth, now that becomes a much bigger problem because any slight deviation that you might have with the line of sight, you might miss Earth completely.
Yeah.
And so that's what we're looking at is looking to make sure that when they point at Earth, that it stays on Earth and it doesn't bounce around. And so that's what's called jitter on a satellite.
Yeah.
And so we're reducing the jitter. The the hardest part with that one is our technical monitor for NASA really wants us to get to about 100 millihertz for the natural frequency, which is pretty much unheard of. Like if you have 5 hertz or 7 hertz, that's probably the lowest that most people go, and they want us to get all the way down to zero point 0.1 hertz.
If you were going to give someone, because again, caveman out here, and there's probably some in the audience, if you were going to give like a relationship of like how much lower that would be, what would that seem like? Like the sun to the earth or something like that? Like I'm saying size wise, like from 5 hertz to 100 millihertz.
Well, and it's a logarithmic scale, so it's like 10x, or it's massive change. It's going from like, sorry, James, I want to add my 2 cents. You tell me if I'm wrong.
Oh, go ahead. Yeah.
So like in terms of isolation, you can think of things like that are stiff or things that are soft. So something that would be a stiff isolator would be like an engine mount on your car. The payload is really heavy and the vibrations are pretty tight. And so it has to be hard really to isolate that vibration, where like your memory foam mattress would be something soft that would isolate vibrations and you're jumping on it, right? So a soft mattress would be high frequency isolator, right, James?
Low frequency.
Sorry, mix that up. So something's hard would be high frequency, something soft would be low frequency, and that difference there is probably the change between the 7 hertz to the millihertz that we're trying to achieve.
Yeah.
So it's a massive gap.
Yeah, it's just when you're going to something that you're already at the bottom limit and you're reaching that, like physically it's hard to do, and so there is like a lower limit that you can't get to. And so coming up with those different things that you can play with, either the geometry, the material, the whatever it is, is always difficult. So even if we were going from, let's say, 1 hertz down to 0.1 hertz, that's like a huge difference already,
Yeah.
even though it might not seem that much, right?
Well,
and then to add, it's got to survive launch. So you got to get it to space first. And then you got all the temperature swings, right? So it's, 20 degrees Celsius on the surface. It's negative 100 degrees Celsius in space. Like that temperature swing changes everything. And then add, how long does it take to get to Saturn? 5 years, 10 years? It has to live that long and then still operate. So it really difficult problems to solve.
Yeah. Well, I'm glad you're working on them and not me, because I don't think we'd get there. It's funny though, you talk about the jitter, and we even talk about that, using a targeting pod to employ weapons and stuff, using a laser, creating high quality GPS coordinates from an airplane. We take that into account, even that short distance relatively. We're worried about our jitter and our graze angle relative and our laser spot size and all that kind of stuff. So I can only imagine when I'm trying to be particular, it's not even in the same ballpark as that kind of need to be particular.
Yeah.
Well, that's pretty awesome. Well, unless you have anything else, I'll let you guys kind of let people know how to get in contact with you.
So you can visit our website, shocktech.com. If you got questions or you want to reach out, you got a problem that you want to have us look at, there's a contact us that comes straight to me and a couple other folks in our company, and we'll be in touch. But James, you got another option?
You can email me. My email is jrall@swg-red.com. And that will get me directly, and then we can, connect that way.
Awesome. Well, thanks for being here, guys. I appreciate it. And then everybody out there, you can contact us at info@kodiakshack.com. Check out our website, kodiakshack.com. And then we have we're getting some sponsors nowadays. So if you want to sponsor an episode, get your name out there. If you can't be on the show, then contact us at info@kodiakshack.com. Donations are always welcome. And then for all the prior military guys or anybody that could be a subject matter expert, we're getting a lot of requests from companies to put them in contact with people who may be smart in some areas. So shoot us an email. Let us know if you're interested in helping kind of be an end user or provide feedback to all these wonderful companies. But thanks for listening, and guys, thanks for being here.
Thanks, Vader. Appreciate it.
You.
All right, see ya.